Problem number 18. Harish, Dilip and Asha start around a circular stadium and complete one round in 27 seconds, 9 seconds and 36 seconds respectively. In how much time will they meet again at the starting point? Again means for the first time what they are meeting you should not consider. Okay, while they start the race, okay, they will be together. That time you should not consider. In the previous problem, yes, you have to consider that one because they have not mentioned after the first time. So you have to consider that one. But in this problem, okay, in how much time will they meet again at the starting point? Again means for the first time while starting the race they will be together. That time you should not consider. Okay, for the second time when they meet, at that time you have to consider. So it is nothing but LCM 27, 9 and 36. So you calculate LCM. So 9 3s are 27, 9 1s are 9 4s are 36. 4 and 3 are co-primes because the HCF between 4 and 3 are 1. So 4 3s are 12, 12 9s are 108. So after 108 seconds it is going to meet. So if you convert this 108 seconds to minute, 108 by 60, 108 by 60 means 6 10s are 60, 6 1s are 6, 6 8s are 48. Okay, 6 8s are 48. Next 1.8, 1.8. So 1 minute and 0.8 seconds. Sorry, 0.8 minutes. So 1 minute and 0.8 you have to convert that into seconds. So 0.8 into 60. In 1 minute you have 60 seconds. So 0.8 into 60, 8 6 are 48. So 48 seconds. 1 minute 48 seconds is the answer. So option A. Option A. So 108 seconds you got. So 108 seconds, if you convert those things into minute, you will get 1.8. 18 by 10, 1.8. So 1 minute and 0.8 minute. 0.8 minute has to be converted into seconds. So in 1 minute you have 60 seconds. Therefore 0.8 into 60, which is equal to 48 seconds. 48 seconds. So 1 minute 48 seconds is the right answer. Option A is the right answer for 18th problem. Question number 19. 3 men A, B and C go walking round a circle of 1 kilometer in circumference at the rate of 10 meters per minute, 20 meters per minute and 40 meters per minute. That is the meaning of this question, 10, 20 and 40 meters per minute respectively. If they all start together and walk in the same direction, when will they again be together at the same place? You know the speed, but you don't know how much time they will take to complete one circle. Okay, they have given the circumference is 1 kilometer. So 1 kilometer means how many meters? 1 kilometer is nothing but 1000 meters. Okay, so how much time they take to complete this 1000 meters we have to check. Okay, so consider A. So A takes 10 minutes, A covers 10 meters per minute. Then A takes 1000 by 10, which is equal to 100 minutes. A takes 100 minutes. Okay, like that you calculate for B. B travels 20 meters per minute. So B takes 1000 divided by 20, which is equal to 50 minutes. B takes 50 minutes. And come to C. So C 40 meters per minute means it is going to travel 40 meters per minute. So 1000 meters, how much time it takes? So 1000 by 40, so 25 minutes. 25 minutes. Okay, so A takes 100 minutes to complete one circle, B takes 50 minutes to complete one circle and C takes 25 minutes to complete one circle. So now we got time. So when will they again be together at the same place? So after how much time once again they will be in the same place at the starting place? Okay, it is nothing but you take the LCM. It is nothing but you take the LCM. LCM of 100, 50, 25. Okay, so 25 4s are 100, 25 2s are 50, 25 1s are 25. Next again 2 2s are 4, 2 1s are. Next 2 1s are 2, 1s are. So the LCM will be 25 into 2 into 2, which is equal to 100. So after 100 minutes again they will meet. After 100 minutes again they will meet. So option D is the right answer for the problem number 19. So after 100 minutes they are going to meet again. Let us go to the next problem, problem number 20. A number when divided successfully or successively by 4, 5 and 6 leaves remainder 2, 3 and 4 respectively. The least such number is, they are asking, the least such number is. So once you divide by 4, it should leave the remainder 2. Once you divide the number by 5, it should leave the remainder 3. Once you are going to divide it by 6, it should leave the remainder 4. So you take the LCM of 4, 5 and 6. 4, 5 and 6. So 2 2s are 4, 5, 2 3s are 6. So all are co-primes, 2 into 2 into 5 into 3. So 4 5s are 20, 3s are 60. 60 is the number which is exactly divisible by 4, 5 and 6, but it should leave the remainder as 2. So for when it is divisible by 4, and it should leave the remainder 3 when it is divisible by 5, and it should leave the remainder 6 when it is divisible by 4. Okay, therefore you see here 4 minus 2, it is 2. Next 5 minus 3, it is 2. Next 6 minus 4, it is 2. So 2 is common here. So you subtract 2 from 60, you will get 58. You will get 58. So 58 is the least number which when divided by 4, 5 and 6, it leaves the remainders of 2, 3 and 4 respectively. 2, 3 and 4 respectively. Let us go to the next problem, problem number 21. The greatest number that divides 43, 91 and 183 so as to leave the same remainder in each case. So same remainder in each case. So which is the greatest number we have to identify. So in this type of problem you go for one method. There is a technique in identifying the HCF where in the case like this. So 43, 91 and 183, it has to be divisible by the number where the remainder will be common in all the three cases. So in this type of case you have a technique, go for the technique. The technique is HCF is equal to modulus of 43 minus 91 comma 43 minus 183 comma 91 minus 183, 91 minus 183. So modulus means even though you get the negative value, you have to consider it as the positive value. So which is equal to 43 minus 91 or 91 minus 43. So 11 minus 3, 8, 8 minus 4, 4, 48. Next 183 minus 43, so 0, 18 minus 4, 14, 140. Next 2, 18 minus 9, 9. So you have to calculate the HCF for 48, 140 and 92. Okay, where you will get the common remainder. Okay, so you calculate the HCF. I am considering these two numbers. Okay, 140 is the bigger number, so it has to be divisible by 48. So 48 how many times? 48 threes are. Okay, so 48 threes are 8 threes are 24. 2 carry over. 4 threes are 12. 13, 14, which is more than 140. You take 2 times. You take 2 times. Okay, 48 twos are 96. 10 minus 6, 4. Next 13 minus 9, 4. Next 44 ones are 44. So 4 is the remainder. Next 4 11s are 44. 4 11s are 44. So 4 is the HCF. Next you calculate the HCF for 4 and 92. For 4 and 92. So 92 is exactly divisible by 4. So 4 2s are 92 is exactly divisible by 4. Okay. So 4 2s are 8, 4 3s are 12. So 23 times if you do, you will get 492. 23 times if you do, you will get 92. Therefore 4 is the HCF. So if you divide a number called 43, 91 and 183 by 4, you will get the same remainder. If you want to cross verify, you can cross verify. If you divide 43 by 4, okay, then remainder will be 3. 4 10s are 40, 3 is the remainder. Next 91 by 4, okay, so 22 4s are 88. 22 times if you do, you will get 88, then 3 is the remainder. 183. 183 by 4. So if you divide 183 by 4, 180. 4 4s are 16, 4 5s are 20. So 45 times if you do, you will get 180. Therefore remainder is 3. So the common remainder is 3. Therefore 21, for the question 21, option C, 4 is the right answer. What is the least number which when divided by 5, 6, 7, 8 gives the remainder 3 but is divisible by 9? Problem number 22. What is the least number which when divided by 5, 6, 7, 8 gives the remainder 3 but is divisible by 9? See, once you divide the number by 5, 6, 7, 8, it should give the remainder 3. But the number should be exactly divisible by 9, that is the condition. So you take the LCM for 5, 6, 7, 8. You take the LCM for these 4 numbers. Okay. So 2, 5 as it is, 2 3s are 6, 7 as it is, 2 4s are 8. Okay. Further, there is no need to divide because all the 4 numbers are co-primes to each other. Okay. So 2 into 5 into 3 into 7 into 4 is equal to, you will get the LCM. So 2 5s are 10, 10 3s are 30, 30 into 7, 210 into 4. So 210 into 4, so which is equal to 840, which is equal to 840. So 840 is the number which is exactly divisible by 5, 6, 7 and 8. But the number should give the remainder 3. So, but the number should be divisible by 9, that is the condition, that is the condition. The number will be like this, 840 into k plus 3, this will be the format. Okay. So k, if you put k1, okay, then the number will be 843. Okay. So 843, once you divide it by 5, you will get 3 as the remainder. Once you divide it by 6, you will get 3 as the remainder. Once you divide it by 7, you will get 3 as remainder, and 8, it will give 3 as the remainder. But is 843 exactly divisible by 9? You have to check. So 8 plus 4 12, 12 plus 3 15. Test of divisibility for 9, you apply that rule. Okay. 8 plus 4 plus 3 is equal to 15, which is not divisible by 9. Therefore 843 is not the answer. Next, 840 into k plus 3. So put 2 here. So 840 into 2. So 1680 plus 3, which is 1683, which is 1683. So 1683, if it is divisible by 5, it gives 3 as remainder. 6, if it is divisible by 6, it gives 3 as remainder. If it is divisible by 7, it gives 3 as remainder, and if you are going to divide it by 8, it gives 3 as remainder. So now we have to check whether the number is exactly divisible by 9 or not. So once again you apply the rule of test of divisibility for 9. So here 1 plus 6 plus 8 plus 3. So how much you will get? You will get 18. You will get 18. 18 is divisible by 9, therefore 1683 is exactly divisible by 9. Therefore option C, 1683 is the exact answer. Option C for the problem number 22. So very simple, you take LCM, so and you add 3 because 3 is the remainder. So 840 is the LCM into K plus 3, because 1 time 840 plus 3, it is not divisible. So for the second time we have to check. So K represents 1 time, 2 time, 3 time. Okay, so 843 into 1, 843. So 840 into 1, 840 plus 3, 843. 843 is not divisible by 9, therefore that is not the answer. Go for 2, K as 2, 840 into 2, 1680 plus 3 is the remainder, 1683. So 1683 is exactly divisible by 9, and if you divide that number by 5, 6, 7 and 8, it gives 3 as the remainder. Therefore option C is the right answer. Till now we have discussed 22 problems which contains most of the varieties which can appear in the exam, the two in the clerical level and in the PO as well as the SO level, okay, specialist officer level. See here, in the 22 problems, almost 15 problems to 18 problems are related to clerical as well as the PO. Okay, so 12 to 13 problems clerical, above that yes PO and specialist officer. So HCF and LCM is very simple, and the number of varieties are also very less. Only thing is you have to calculate the HCF or the LCM, but in a different manner. Only thing is you have to understand the question, what they are asking, what you have to identify, whether you have to identify the HCF or the LCM. One thing you have to remember, if you want to check the divisor, okay, which number is going to divide, if you want to check that one, it is nothing but you have to calculate the HCF, highest common factor, greatest common divisor. So which number is going to divide, if you want to check that one, means you have to identify the divisor, that is nothing but the HCF. And next, which number is going to be divided from the other number, if you want to check that one, means it is nothing but the dividend. You have to calculate LCM for that number. Okay, so this is the two major hints. If you remember these two hints, definitely you can solve any type of the problems. Okay, so please practice these problems. One problem will be there definitely for clerical as well as in the PO, where in the PO you can expect a bit higher difficulty level, and definitely if you practice these type of varieties or these varieties what I did today, okay, if you practice these problems, definitely you can solve any type of problem which will come in the exam.